In this video, I am going to discuss the division algorithm. Now, the division algorithm is not really an algorithm. It's really just a theorem that says what happens when we go through the algorithm of division. So for example, let's consider this problem from grade school, 22 divided by 5. Now, if you were to go about the algorithm of division, what would happen? Let's see, you would do something like this. You would say 22 divided by 5. 5 goes into there 4 times. 5 times 4 is 20. Subtract. Your remainder is 2. Okay. Now think about what that means, another way to write this. So in grade school you might have also learned that another way to express all of this is that 22 is equal to 5 times 4 plus 2. Now in the language of the division algorithm, 22 is the number n, 5 is the divisor, d, 4 is the quotient, q, and 2 is the remainder, r. All right, but there's a little bit more to the division algorithm than just this. And I'll show you that in the next example. So on the left, I'm going to do the division 10 divided by 3 incorrectly. And on the right, I'm going to do the division 10 divided by 3 correctly. Okay, so first, the incorrect way. And over here, we'll do correct. All right, so 10 divided by 3 incorrectly. One way to do it incorrectly would be to say that 3 only goes into 10 2 times. 3 times 2 is 6. Subtract. You get 4. You have a remainder of 4. All right, so notice what's incorrect here, right? The thing that's incorrect is that 4 is bigger than 3. 4 is bigger than 3. In other words, the remainder is bigger than the divisor. That's the thing that tells us that it's incorrect. And you probably remember this from grade school. How do you know? What's one way to know that you should redo your work if your remainder is bigger than the divisor? Okay, and similarly to the last example, this tells us that 10 is equal to 3 times 2 plus our remainder, 4. Now notice that this is a correct statement, that 10 is actually equal to 3 times 2 plus 4. All right, now let's look at the correct way. So we all know 3 goes into 10 3 times. 3 times 3 is 9. Subtract, you get a remainder of 1. And that this leads to a correct statement as well. That is that 10 is equal to 3 times 3 plus 1. All right, so here's what's going on. Remember that the division algorithm tells us that when we divide n by some divisor d, d goes in q times plus some remainder. Well, it also tells us more. It tells us that the remainder is greater than or equal to 0 and less than the divisor. Now notice here, our divisor is 3 and our remainder is 4. So it's not true that it's false that r is greater than or equal to 0 and less than d, right? Because it's not true that 4 is greater than or equal to 0 and less than 3. 4 is bigger than 3, right? So that's why this example is incorrect. Now notice what happens over here. And think back to your intuition, right? Your intuition would tell you this is incorrect because 4 is bigger than 3. The remainder is bigger than the divisor. Okay, so over here on the right, on the correct one, here d is equal to 3 and our remainder is equal to 1. And so it's true that 0 is less than or equal to r is less than d. Because this says that 0 is less than or equal to 1 is less than 3. That's true, right? We see that's true. So this is what the division algorithm is all about. It's really just formalizing your intuition from grade school that your remainder has to be less than your divisor. And our remainder can't be smaller than 0, so we do that. Now, as a last example, let's consider the general case where we have n is divided by d. All right, so if we were to do this using the same sort of method that we did before, we would see that d divided into n, it goes in some q amount of times. Let's see, if you do the multiplication, you've got d times q and subtract. And what do you get? You get some little remainder r, some little r for the remainder. Your remainder is little r. This tells us, right, that n is equal to d times q plus r. And as we know, r must be, greater than or equal to 0 and less than the divisor. Now something else that's I guess somewhat interesting to think about is n here, right? Because of the division algorithm, we know that this is dq plus r, right? So d going into n, I'll rewrite n as d times q plus r, right? Remember, this is n. Well, we said above, right, that it goes in q times. And look what happens. D times q, that gives you d times q. Remember, you do this subtraction thing, right? And then, so dq plus r minus dq, that gives you a remainder of r.